What's up, my mathletes? This is Miss Muscarella coming at you, and in this video, we're going to take a look at using the unit circle. That's right, using all those values around the unit circle, which you have been so patiently and diligently memorizing for some time. So let's go ahead and put that to use, shall we? All right, let's go. Now, one of the things we want to talk about with the unit circle are these 4 points right here. The unit circle itself is based on a radius of length 1 unit. And where that comes from is basically taking one of your special right triangles, either the 30, 60, 90 or the 45, 45, 90, and finding the hypotenuse and changing the ratio of that to be 1. And so here's just kind of a little quick demo on that right here for you. So if you had the right triangle right here, okay, and say this angle in here was 45 degrees. Then I know that the ratio around the two legs is both 1, and then the hypotenuse has a side length of square root of 2. However, in order to get that to be 1, right, we've got to divide everything by square root of 2. And in order to do that, you know, that will give us a hypotenuse. So this part I'm highlighting in green. That part is now going to have a value of 1. Now, unfortunately, we don't like having a square root in the denominator here. So we've got to go ahead and rationalize that for each one of the legs. And in this case, each one of the legs would be square root of 2 over 2 when we do that. Same kind of idea with the 30, 60, 90, but you get the idea. So the key thing, though, is that the hypotenuse has a length of 1. Now, the x-coordinate, when we look at the coordinates around the unit circle, the x-coordinate is going to be the cosine value. The y-coordinate will be the sine value. And one of the ways that I always remember that, so please go ahead and write this down, cosine and then sine. So these are going to be the two values that are in the parentheses around the unit circle. Now, just alphabetically, if you think about it, if A, B, C, D, E, F, G, I don't remember what I'm supposed to be. So here we are. So X comes before Y in the alphabet, right? So C in cosine comes before S. So that's one way to remember that. So we have cosine and we have sine. Those are going to be the X, Y coordinates around the unit circle. Now, in this diagram that I have here for the unit circle, the red values are around the outside, those are all of the tangent values. And you get the tangent value by one of two ways, either dividing sine by cosine or the y-coordinate by the x-coordinate. Whichever one of those ratios you want to use, that will give you the values that you see around the unit circle here in red. So now let's go ahead and take a look at these values. We're going to use some in radians and some in degrees. So first we're going to take a look at the sine of 315 degrees. I'm not sure why, but they should have been numbered. So that's 1, that's 2, that's 3, and then that's number 4, then 5, then 6. I don't know. So if we look at 315 degrees and I want the sine of that, then that tells me, so in my brain I'm thinking to myself, I've got to look at the y-coordinate at 315. So I go over to 315 degrees and I'm like, all right, 315 degrees. Oh, that's right here. That's right here. And I want the sine, the y-coordinate, so that's this part right here. That's negative square root of 2 over 2. So that's all I got to do. Just write down negative square root of 2 over 2. And that's it. Cosine of 120, so now I'm going to 120 degrees, and cosine is my x-coordinate, right? So I'm going to go to 120 degrees on the unit circle, and from there, I'm going to take a look at the x-coordinate, which in this case is negative 1/2. So the value of cosine of 120 is going to be negative 1/2. All right, so those are all the values around the unit circle. Tangent of 135, so I would go over to 135. And notice, now I'm looking for that value in red around the outside, and that gives me just plain old negative 1. Now, if I wanted to take sine divided by cosine, the y-coordinate divided by the x-coordinate, I would end up with that same value. So you can go ahead and pause the video if you want, or we can go ahead and do the same things, but this time examples 4, 5, and 6, they're in radians. No big deal, bro. So go ahead and pause the video and then come on back and see how you do with the values for numbers 4, 5, and 6. All right, so how did we do? The sine of pi, so if I look at pi on the unit circle, that's where 180 degrees is. Sine is the y value. And be really careful here because a lot of people want to put the negative 1, but it is just 0. Sine's the y value, and that's 0. Cosine of 4 pi over 3, same as 240 degrees. If I want cosine, that means I'm looking at the x-coordinate, which again is negative 1/2 in this case. And then lastly, we've got tangent of 3 pi over 2. Now the tangent of 3 pi over 2 is undefined. Undefined. And again, if you can remember the y-coordinate divided by the x-coordinate, so we would have negative 1 over 0. Anything divided by 0, bro, undefined. There's one exception to that, and you'll learn about that later in another math class. But right now, negative 1 divided by 0, it is undefined. So can't do that. All right, so those are the first 6 examples. So hopefully all you got to do is hunt down the unit circle. Remember that sine is the y-coordinate. X-coordinate is going to represent cosine. That's all you got to do. Find that value in the unit circle, and then boom, diggity, you're done. So that's it for this video. Thank you guys for watching. Now we'll finish up 2 other pieces with the other 3 trig functions, the reciprocals of sine, cosine, and tangent. So make sure you come on back and watch that one, and I'll catch up with you guys later on. Peace out.